So next topic is cache memory. And then introduction to cache memory, locality of reference, cache hit and cache miss. Cache mapping techniques. There are three techniques for cache mapping, that is direct mapping, associative mapping and set associative mapping. So what is cache memory? The processor is much faster than the main memory. As a result, the processor has to spend much of its time waiting while the instruction and data are being fetched from the main memory. This is a major obstacle towards achieving good performance. But the speed of the main memory cannot be increased beyond a certain point. Cache memory is an architectural arrangement which makes the main memory appears faster to the processor than it really is. So cache memory is based on the property of computer program known as locality of reference. So we already know that we have the cache memory, the processor is faster, and we have the main memory. The main memory is usually the RAM. So the RAM is not as fast as the processor. So to execute an instruction, when a memory fetch is done, the processor has to wait for the to get a data from the memory or to write a data to the memory, because the speed of the memory is less compared to the speed of the processor. To overcome that issue, we came into the concept that it's a cache memory. The cache memory will be a faster memory than the main memory. We studied about the RAM cells. The main memory is dynamic RAM and cache memory is static RAM. So the static RAM is much faster compared to dynamic RAM. So cache memory is faster memory than the main memory. But the cost of the cache memory will be, the cost of the static RAM is high and compared to the dynamic RAM. So only a small amount of cache memory will be allocated in a processor. The cache memory is based on the property of computer program known as locality of reference. So what is locality of reference? Analysis of programs indicates that many instructions in localized area of a computer are executed repeatedly during some period of time, while the others are accessed relatively less frequently. So when we want to access a particular instruction or data from the main memory, the data near to that indicated space or the indicated memory will be accessed soon. We know that the instruction, if we are fetching an instruction, the instructions will be executed in a sequential manner. So the instructions near to the instruction that is requested now will be executed more frequently or more in the near future. That is the locality reference. So these instructions may be the ones in a loop or nested loop or few procedures calling each other repeatedly. This is known as locality of reference. So that means when we want to get a data from the memory, the data near to that the data placed in the near location to that location will be accessed frequently. That concept is called locality of reference. നമ്മളിപ്പോൾ മെമ്മറിയിൽ നിന്ന് ഒരു ഡേറ്റ വേണം, ഇപ്പോൾ 2000 ഹെക്സ് എന്നുള്ള ഒരു ഡേറ്റ ആണ് നമുക്ക് എടുക്കുന്നതെന്നുണ്ടെങ്കിൽ ആ 2000 ഹെക്സിൻ്റെ അടുത്തുള്ള ആ 2000 നിയർ ടു 2000 ഹെക്സ് ലൊക്കേഷൻസിലെ ഡേറ്റ ആയിരിക്കും നമ്മൾ ഉടനെ നെക്സ്റ്റ് ആക്സസ് ചെയ്യാൻ പോകുന്നതെന്നുള്ള ആ ഒരു കൺസെപ്റ്റിനാണ് ലൊക്കാലിറ്റി ഓഫ് റെഫറൻസ് എന്ന് പറയുന്നത്. These two types, temporal locality of reference and spatial locality of reference. So recently executed instruction is likely to be executed again very soon. That is temporal. So what is recently executed? That instruction will be executed very soon in the near future. That is temporal locality. And spatial locality means the instruction with address close to a recently executed instruction are likely to be executed soon. That is spatial locality. This is the same instruction will be executed repeatedly. That is temporal. And spatial means the instruction near to that instruction will be executed next or in near future. That is spatial locality. And this is the idea of a cache memory. That is, the cache memory will be placed between the processor and the main memory. We have already seen the hierarchy and the construction. So cache means different levels of cache will be there. Level 1 and level 2 cache will be placed inside the processor, and level 3 cache will be placed out between the main memory and the processor. The processor issues a read request. A block of word is transferred from the main memory to cache, one word at a time. So when the processor issues a read request, a block of word will be transferred from main memory to the cache memory. That the transferring will be done one word at a time. So subsequent references to the data in this block of word are found in the cache. So when requesting word, a complete block will be transferred to the cache memory, and subsequent reference to the data is in this block of word are found in the cache. At any given time, only some blocks in the main memory are held in the cache. Here we said that the size of the main memory is larger, but the cache memory is smaller. So we cannot place all the data in the main memory to the cache memory. So only a few data or some blocks of the main memory will be placed in the cache memory. So which block in the main memory are in the cache is determined by the mapping function. There is no space for all the blocks to place. Only a few blocks will be placed in the cache memory, and which block is placed in the cache, it is determined by the mapping function. When the cache is full and a block of word need to be transferred from the main memory, some blocks of word in the cache must be replaced. So this is determined by replacement algorithm. So we have mapping function to place a block of data from the main memory to the cache, and we have replacement algorithm. That means we need to place some data into the cache, but the cache is full. We need to get some space, allocate some space for the block to be placed in the cache. So some of the blocks will be replaced and the new block will be placed. So this is done using the replacement algorithm. So cache hit. The existence of a cache is transparent to the processor. The processor issues a read and write request in the same manner. If the data is in the cache, it is called a read or write hit. So hit means the processor request, when a read or write request is issued, the processor will search for the data in the cache memory. If the processor gets that data from the cache memory, it is called hit. If the processor issues a read request, then it will be read hit, and if the processor issues a write request, it will be write hit. Read hit is the data is obtained from the cache. So the processor needs some data, so I want to read the data from the main memory. The processor searches for the data first in the cache. If the processor gets the data from the cache, it is called read hit. So write hit means the cache has a replica of the content of the main memory. The content of the cache and the main memory may be updated simultaneously. This is write-through protocol. So we need to write some data to a particular memory location. Some of the blocks of the main memory will be placed in the cache memory also. So if the particular location or the block that we need to write the data is available in the cache, it is called write hit, and the data in the cache is written into the cache and the main memory simultaneously, means write through protocol. So if the data is updated or the content of the cache and the main memory be updated simultaneously, it is write through protocol. Write means we want to store some data to the memory. So the particular block, if the particular block is placed in the cache, and also the block will be placed in the main memory. So when we are mapping a block from cache to mapping a block from main memory to cache, the copy of that block is placed in the cache memory. So the same copy will be placed in the main memory as well as in the cache memory. So when we are writing a data to a particular block, at the same time if we are modifying or altering the contents of the main memory and the cache memory, it is called write through protocol. The update of the content of the other option is that first we will update the content of the cache and mark it as updated by setting a bit known as dirty bit or modified bit. So there is another method of writing to the cache. The write bit is that first we are altering the we are writing the data to the cache memory. So there will be a bit called the modified bit or dirty bit. So we will set that bit updated such that it indicates that the data in the main memory and the cache memory is different. That means the only the content of the cache memory, we store the data only to the cache memory. So the content of the main memory are updated when this block is replaced. So when the cache is full, we will replace this block to allocate a new block to the cache memory. So at the time of replacing, we will alter the content of the main memory. That protocol is called write back or copy back protocol. That means at first we are replacing when the processor want to write some data to the memory. If that block is placed in the cache, then we will write the data to the cache memory only, and then we will set a dirty bit or a modified bit to indicate that the content in the cache memory is updated. So while replacing the block, we will change the content of the main memory. So this protocol is called write back or copy back protocol. So we have cache memory and main memory. The copy of data in the main memory is placed in the cache memory. So whatever the data that we are placing, blocks we are placing in the cache memory, the same block will be there in the cache memory. Not cut and paste, we are only copy and pasting the content of main memory to the cache memory. So next is cache miss. If the data is not present in the cache, so the processor requests for a data or a read or write operation. If it is not present in the cache, then a read miss or a cache miss occurs. So that is miss. If the data is available in the cache, it is called hit. If the data is not available, it is called miss. So read miss, the block of words containing the requested word is transferred from the memory. When a read miss occurs, the block of word containing the requested word that will be in the main memory, that will be transferred from the main memory to the cache memory. After the block is transferred, the desired word is forwarded to the processor. The desired word may also be forwarded to the processor as soon as it is transferred without waiting for the entire block to be transferred. This is called load through or early restart. So when a read miss occurs, we need to take the block from main memory to cache memory. So we are transferring the transferring of data from main memory to cache memory will be done one word at a time. So after the block, when the block is transferred, the desired word is forwarded to processor immediately. That means where the desired word also should be forwarded to the processor as soon as it is transferred without waiting for the entire block to be transferred. This is known as load through or early restart. And write miss. Write miss means write through protocol is used. Then the content of the main memory are updated directly. So write through protocol means that when we have to write some data to the cache. If the cache doesn't has that particular block, the block is placed in the main memory. So the content of the main memory are updated directly. That is write through protocol. So the second method is write back protocol. Write back protocol is used when the block containing the address word is first brought to the cache and the desired word is overwritten by the new information. So first we are placing it in the cache and then overwriting the information. This is cache coherence problem.